Nowadays, quartz-based sensors are limited by the miniaturization process and the monolithic integration of this material on silicon. These bottlenecks are now overcome with the first chemical integration of epitaxial piezoelectric quartz MEMS in the form of high-quality microcantilevers. From a technological perspective, these novel quartz devices open the door to the development of cost-effective active microelectromechanical system engineered from lead-free piezoelectric oxide materials and providing high forces and mass sensitivity while preserving its quality factor.
Begin by mixing 1 part of the curing agent with 10 parts of elastomer in a beaker on the balance. Stir this mixture with a glass stick until a homogeneous distribution of air bubbles is obtained. Then fill the master with PDMS and remove the bubbles in a vacuum chamber. Introduce the PDMS and silicon master into a stove at 70 degrees Celsius for 2 hours. Replicate the silicon master using the PDMS solution as described in the manuscript. Prepare 2 by 6 cm sized substrates by cutting a 2-inch P-type SOI wafer in a direction parallel or perpendicular to the wafer flat using a diamond tip, ensuring that the conductivity of the silicon device layer is between 1 and 10 ohms per centimeter. To eliminate possible fabrication polymers, introduce these substrates into a